Okay, this one's a qualification certificate one in engineering, and my name's Tim Clements. So this is one of the units of competency within the certificate one in engineering. Emergency procedures, out the front door you come, we'll follow the little green man, running man signs, always the best way. This one is unit of competency, and this is the performance of engineering measurement. Right. So what we're going to do is refer to these charts very briefly. There's only 2 lines you're going to look through, so don't overlook the charts at the moment, but I'll get you to run through it. We're going to go through dimensions, but the key one of this unit is, I'm going to tell you how to turn millimetres into thousandths of an inch. Right? Okay? And how to convert that. And believe me, it's very, very simple. So, it's basically either times or dividing. Okay? So, just let us get to that, but we're going to stop and go back and forwards with it. But it's amazingly simple to change it over. Okay? So we're going to do basic conversion to imperial to metric. We're going to look at the micrometer, which we've seen before, the vernier. Right? These are the 2 instruments we measure fine measurements with. And then I'm going to show you at the end of it a tolerance and clearance and why these fine measurements mean something. Okay? And why you actually undertake these sort of things. Right? In the reference chart you'll see a very simple columns. Right? And don't overread this chart, but I don't. Right. Just stick on one side here. See these grey ones here? Dark grey. Right? Everyone have a look at that? Yeah. That's inches. Right? See the light grey next to it? That is equivalent of what an inch measurement is in thousandths of an inch. And what, see the blue one? That's what it is in millimetres. Okay? Now, to convert from one to the other, it's so simple it's frightening, is just timesing it and dividing it by 25.4. That's it.
That's it.
That is it.
That's it. But
that's changing from millimetres to thousandths of an inch. Now I'm going to tell you, you all know what millimetres are, and we've brought up the metric system. The thousandths of an inch, I'm going to explain what that is in detail. This is where you stop and ask again, okay?
Okay.
And again, but it's very simple if you just look at it in basic terms. The metric system's in multiple 10. We're all done it to death at school, and we understand where that comes from. Now, when we talk all these measures, we're going to be talking in millimetres. Don't think centimetres or anything else. Most of the things machinists measure are within this big. We do very large things, but 90% of it's this big or less. Okay? Most of the fine measurements in that size. You know, there's larger things certainly, much larger, but most of it's doing this sort of depth, size. Right, this is the bit where you stop and ask multiple times, because if you haven't dealt with it before, you need to get it in your head. The imperial system, for every inch, there's 1,000 measurements. Okay? So for every inch, there's 1,000 thousandths of an inch.
So an inch is 2.5 centimetres?
We don't do centimetres. 25.4 millimetres.
Yeah, I know, but I've got to, so that be to
That big is an inch.
Yeah.
An inch. So when you look at your chart, okay, and this is the bit where you stop and go, hang on, I didn't get that. Half an inch is basically, no, don't think in metric of this part, right? So an inch, that written is like this. So 1 inch equals 1,000 thousandths. Okay? Half an inch equals 500. And that's as simple as it goes. So when you look along these charts, so everyone find half an inch in the dark grey, right, coming down here, it is here, right? Next to it is comma, 550, 500 thousandths of an inch. Okay? So that's what half inch there. So a quarter would be 250. And that's all you need to know. There is a thousandths of in an inch. 1,000 thousandths, and these commas represent thousandths. So when you see a measurement that has this comma and these abbreviations, you're talking in inches, thousandths of an inch. In millimetres, it's like this, isn't it? Where an inch is 25.400. So when you go to an inch on this sheet here, right, in the dark line, you've got half an inch, there's 500. You follow it down through, you find an inch, you go across, there's 1,000.
Jim, can you come in for a second?
Yep, absolutely. You've got to get this.
Yeah.
This is what you do, and it helps if you've got one of these things
Can
too.
you, because we actually can't see, we can see the Can you just, what
Okay.
number are you looking at, Tim?
So look at this grey column here,
Oh, the dark grey, yeah.
and that's
So that's a quarter.
quarter of an inch. Under quarter of an inch is 250,000.
Okay.
Under half an inch is 500 thousandths of an inch.
Oh, yeah, so we're looking at the grey lines.
Yeah, that's it.
Yeah, okay, cool.
yeah. And when you get up here to an inch,
Yeah.
there's 1,000 thousandths in an inch.
So it starts off small and it gets bigger.
Bigger.
Oh, okay, cool.
Yeah.
So that there is like tiny, and that's 1 inch.
Yeah, and if you want to look across an inch, it's 25.4, and when you look across here, you're barely talking 2 millimetres.
Now we get it. Sorry. We
No,
just
don't.
see-
And
Sorry.
it's important you stop and ask if you don't, because this is the only bit you really probably haven't never touched before,
Yeah.
and people don't talk in thousandths of an inch. They talk about an inch, half an inch, quarter of an inch, nothing. But this is,
No, that's
one
good.
that's
So
probably
that's what
new
we're
to you.
following.
Yeah.
We're
so
up to
you get it to a degree? Yeah, good. So yeah, once again, if you look down an inch, thousandths, half an inch, right, is 500. Okay? Quarter, yeah, quarter of an inch is 250,000.
Everyone is millimetres and centimetres and
Yeah.
well,
Good.
they just.
No, it's good. Okay, we'll just hold it there for a minute. If we all get that, right, let's go through this. So let's go through this if we can. Imperial system, for every inch there's 1,000 thousandths. I know that's bad terminology, but that's what they do call it, 1,000 thousandths.
Yeah.
Okay? So in 2 inches, there's 200 thousandths of an inch. Okay? So in metric, you would write it 38.10, say, and then millimetres after it. But when you, so this explains what you have to do for millimetres, it's 38.1. So when you write it, it's how you write it is important. Right? 3 decimals. Right? When you write it at thousandths of an inch size, you must put a comma and 2 ticks after it. So when you look at a drawing, you can tell. Okay? That's how they write it. That's 10 hundredths thousandths. Right? Okay? So when I would write this here, it would be 0, comma, and that's thousandths. This is millimetres. We're all seeing, say, 9.320. We know it's millimetres. Okay? They don't put anything behind the thousandths. They just do these here. Dedicated. When you write a millimetre measure, you would do that in millimetres. Okay? So, you got the imperial metric number, and that's how you write it. Imperial number, so 1.5 inches, like I said, 1.5 inches equals 1,000. Okay? So that's 1 inch, 500 thousandths, which is half an inch. That's as difficult as this gets. This is it. If you get that in your head to some degree, that is as difficult as it's going to get today. That's it. Okay? But what I'm going to show you is, I'm going to show you one number, how to turn that into a metric number, and a metric number into that. by just simply using one number. Okay? And this is how all machines do it.
25 or 24?
Okay. Before I go too much further, you're thinking, why am I showing you sticks and rock measurements? Okay. And it's a very good question. Everyone's metric. Well, I'll put it into context for you. The biggest manufacturer of earth moving equipment in the world is Caterpillar. And it's from America. Everything's imperial. Okay? So it is relevant as it is today, as it was before, and more relevant for machines. So you would easily have a Caterpillar engine driving a hydraulic motor that was metric. So as a machinist, I would make one end an imperial shaft, the other end driving a metric shaft. Okay? So in machinist world, this is never going to go away. Because America is not going to go to metric suddenly and decide to make all this stuff metric like the rest of the world. Okay? So, and that's the way it is. Okay? And that's bolts, everything.
Everyone should just stop buying from them.
Yeah. Okay, so that's the reality. So when I say we're learning this for a reason, that is the solid reason. There is nothing unusual to get two pieces of equipment you've got to make join together.
I'm going to write to the president.
Okay, and join them together and make them work together because you have to do this. So what I want to do this for, and why you convert these things, is I'll be given a shaft that I have to measure up. One end's imperial, one's metric. Then I've got to go to a metric lathe and make it. So I've got to turn imperial into metric. So when I go to the lathe, all imperial measurements have been written down into metric. So I can drive the lathe, do all the measurements and cut it, all in metric, even though it might be some wild number that doesn't add up to something. In a metric system, like it's generally halves of that, it's not sort of 38.1767, because then you know it's an imperial number, but you machine it to that, because you're driving a metric lathe. So when you get a piece of equipment, it could either be from one end to the other, and knowing how to convert it very simply allows you to drive a machine. Similar, I drive imperial machines. So I'll get a metric lathe, the whole thing will be in metric, but I'll turn it all into imperial, because when I'm driving an older machine, which is playing all around still imperial, I have to make it to imperial measurements, which is thousandths of an inch. Okay? So that's why it's relevant. This is not something you just think, oh, learning it for no reason. Machinists use either of these every day. Okay? Right. Now, how to do the conversion. So what you've learned why we bother doing it. Why now we're going to do the conversion. And this is very simple. Give me a ring. No. So, very simple. That. Points to that. There we go.
See, farmers have to use a fair bit of this stuff too, Tim, believe it or not.
Yeah, bolts.
So, well, not even that. So when the machinery come over, like different machinery on, they have to match up. Some of the stuff that they have to know is more intense than people would think.
And also, look, I'll give you simple as that. We all know a dump truck, one that just tips dirt, dual axles on the back. When people order these sort of things, they can choose what engine they want. Okay? So they get a choice of engine into these bigger trucks. And it's not unusual to order a CAT engine, but everything after that CAT engine is metric. And I'll give you an example. On an engine, you'll say, we're looking at the back end of the engine, there's the flywheel, right? So we've got the engine. Right, that's the back end of the flywheel spinning around. They've got these things called power takeoff units on these engines. That's a spot here and here where we can drive hydraulic pumps off and so forth, or a compressor, or all that sort of stuff. So this drives the truck around, it drives the axle, but these power takeoff units here, in here, will have a spline or a shaft that you can bolt a hydraulic motor to or a compressor to. Well, I've got to make something go from imperial to metric, because this is an imperial CAT engine. Most hydraulic engines, pumps come from Europe. They have to make one go across. So when you talk about a mix and match, all the time.
All the time.
All the time. So it's relevant. Now, I'm going to tell you how to convert this. Okay? And it's so simple, it's frightening. And if you remember this number, you'll be able to convert to imperial measurement, right?
You can use that spray bottle.
You reckon this one?
Yeah.
Yeah, I've never noticed
Or
that.
one, yeah. And then, yeah. And then,
There we go. Pop it up and down the right one. We'll give it a go. Alright,
You've got to read that up.
okay. The only one number that you have to remember. 25.4. So if you got say you got an inch and a half, or say you all got metric verniers,
Yeah.
right? So you may measure it, right, and go it's 38.1. Well, you know that metric wise that's not 38.1, okay? Because they don't make a metric size. They either make it 38 or they make it 40. They're not going to make it in between. So you can do a backwards conversion or a forward conversion. So if you end up with measure something, let's go to the bottom one, that's 38.1, and you measure it and go, they haven't made a metric size that, okay? That would just be simple. You can divide it by 25.4, right? And you'll come up with imperial measurements. Now, I'm sure everyone's got a phone.
I need a calculator.
Yeah.
Yeah.
Oh, she was going to work it out by
Oh, I mean, if someone's got a phone and so forth on their phone, just get a calculator. So if you get 38.1 and divide it by 25.4, you're going to come up with a number. Is 1.5, which is 1 inch, 500 thousandths. And I always put reality. We're only talking measurements bigger than this, so if you're not sure if you should divide it or times it, just do both and reality will kick in. If you've got 38 mil, it's roughly an inch and a half, or 2 inches. Everyone knows what an inch is, everyone knows what 2 inches. So if suddenly you come up with this ginormous number, you know you've got to times it instead of divide it. Okay? And that is all you have to do in machining. You go one to the other. If you want to go the other way, right? Measure something and it measures out at, and you've got an imperial measurement, right? You times it by 25.4, it'll tell you exactly what it is in metric. Okay? That's the only measurement the machinists use. That's the only thing we do to change it from thousands to metric. No more, no less. And it doesn't matter how big the number is, this works. And the reason is 25.4000 is exactly 1 inch. So that is the conversion. So 25.400 divide or times will allow you to go from thousandths of an inch. And if you go to thousandths inch, you know that's half inch. So say, you know, just do a number that's will end up larger, say 140.1 divide 25.4. What does that come out as? Sorry? 5.10. And just talk reality, okay? 140. And keep it in this 140. It's just less than 6 inches, isn't it? Right? That's it there. 5 inches, 510 thousandths of an inch. Okay? This is the only thing we're going to learn today, is how to do that.
Yeah.
And that, once you know what a thousandth of an inch involves, and you can divide it by 25 before you can move between metric and imperial and fine measure. Okay?
So really, when it goes to 6, the 7's higher than 5. You're going to go.
And we're going to reinforce that now, and I'm going to give you a sheet with some drawings on it.
They want you to take it to
You right, ladies? Just wait a minute, is there a question?
You're always,
Oh,
when
we're
you
just trying to read the
when
calculator.
you convert it into inches, you're taking it to
Shut up, Ev.
the,
No, it's good.
to the 3. You
Yeah.
take it to the 3
To
every
the
time. You
three.
won't round
So
it off.
I was
Oh,
saying,
You won't round
really,
it, so that will
that
always be
should
that.
be
No.
5.515.
Yep.
So then I said to Nikki, what do you do? Do you round the 7
No,
up?
just leave it.
So you always take it
Because
to
see
the
that number
3.
there, the fourth number? you wouldn't even be able to measure it.
No, but that's
That's how
what
fine
we were
it is.
just saying.
She was querying the 510. She wanted to know why you did O instead of
Yeah,
5.
I was like, did you round it
Oh, okay.
off?
And that's what she was asking.
Oh, right, I got bothered. Hey?
Oh, yeah, I did say that.
Yeah, okay, sorry.
I thought it was
Good question.
No, we were just wondering if you were rounding things
Nah,
off.
don't round it off. The numbers under here, right behind that, are
Yeah.
so fine you're never going to
No,
make it.
no,
Just thousandths of an inch, right?
it's all good, we just wasn't sure.
Yeah, no, you're right. If I wrote it down wrong, that's what it should have been. That thousandths of an inch is a small measurement.
Yeah,
You're not going to get, there's only specialised people that make things less than that.
yeah.
And they're not machines, they go further into it.
Or poor men had
Okay. Now what we've got here, and I don't want you to freak out on this sheet. Right? Hang on. This is a very simple drawing, and one half of it's metric and one half is imperial, but it's a worksheet. And I don't care if you only do one or two of the measurements on it, write your name on it, and I'm going to walk around, but just keep it in your mind. It's this big. 80 mil, it's that big. So suddenly you get 27 inches and it's supposed to be about this big, you know you've got it wrong. You need to divide it instead of times it, say.
Yeah.
Okay? So sometimes I don't remember if I should divide it or times it. I just do it and go put it into reality. You know? 80 mil, and this is the scale that big. There's no way it's going to be 27 inches or something like that. So just keep it in your mind. And even down the track, divide it with times, but just to keep the reality of the size that you're talking about. Okay?
Really? For young boys, they're thinking about their weddings out, but they're not really.
Yeah.
And this is some of the, we converted a huge amount of measurements, and this is the only one that we use to go from imperial to metric.
Reality, I'm talking reality.
So just put your name on it, and this is not so you do all these measurements, it's just simply to show you how this is a very common shaft, okay? This is something I would make, okay? And this is the scale. So one end of the whole thing is imperial, and it's got a 1/2 inch kilo. This one's got a 12 mil kilo. This is 40 mil, this will be 1.5 inches, which we all know is 38.1, okay?
Right. Yeah, hang on.
So just do a couple of them, don't do all of them, so and just pick a number out. So if you've got one there that's 1 inch 750 thousandths, do the measure, time it, we'll divide it, and come up with what's that, and just scribble on the sheet. That's metric size, metric size.
So
Oh,
this is
this here.
750.
Just pick a couple of numbers, so 50, you know it's going to be less than 2 inches. So here you would divide 50
Yeah.
25.4, and you would end up, just scribble on it, you would end up what that is imperial.
And you divide that one.
No,
Is that
so
what you
50
got?
divide 25.4,
Yes.
Is that
What's the
what you
answer?
got? Point, comma, 750.
Oh, which one did you do? Convert the half
Yeah.
inch.
Yeah.
so you just write next to that, 1
I think you would
I
dash,
haven't done that
no
one.
dash, you do a dash
Well, what
for,
is it?
so the dash is an imperial
Usually
number,
half inch should
Yeah.
be
Oh,
about
that thing.
12.
and you do 3 numbers after it,
Half
and
of 20.
that's 1 inch,
Should
968,000,
be 12
which
point
would
something.
be about right, because 50
It's
mil
a
is
lot,
about 2
so
inches.
if you divide
That's
that
new
by
inches.
2.4,
And for this one you do the.
what's 2.5
Times.
24.
So you've got 1 inch, 750,000, so that's less than 2 inches,
Is that
Times the
right?
times 25.4,
Do you
25.4, and you'll
Yes,
come out with
yeah,
what
no,
that
no,
is
look,
in
I got
metric.
it, I got it. Yeah, so here's a calculator.
So just
when
do that
it's
one and come
right,
out,
You
draw it.
have to divide.
So
Right,
So
so
half,
40,
so
divide,
1 inch is 25.4, half an inch is half of that.
yeah, so then we divide by,
So the 40,
yeah, so I'm dividing that, so I'm getting 1.574, is that right?
perfect. And you know, because that's 40, it's less than 2 inches, and you've got less than 2 inches that has the answer
Yeah,
one.
so here,
You put 1,
oh shit.
Just up here.
Where did that go?
just up here,
Can you get it back? No, hang on.
so you can get a grip of it.
No,
25.
I'm trying to do that one.
Yeah, because this one's a thou, it's an inch, right?
Right,
So
so-
you go 1, 750, okay? And you know you're going for a bigger number, so times 25.4 will turn it into a metric number. So that size there is 44.40 millimetres.
Well,
So,
I think I got it wrong
Tim.
because I didn't do 1.75
What do you wanna do with these things here?
Don't worry about that,
Just
that's
forget
just
about
something.
that.
Oh, that will come in later when I show you tolerance.
So 1 in 21 over 32, so we would go, will I now
Well,
go
Okay,
32 divided
No,
by 21?
I didn't put that
divided
in there to
by
show you, so you can look up here what 2132 is. Right. So next to that, there's 1 inch, 1 inch. What's that? 656.
5, 6, 3.
Okay, yeah, that's enough, right? So just 3 numbers after the dash.
So,
So then I would go 1 point, which was what I was doing.
1,
6, 5,
6.
I would have thought that was supposed to be.
Times.
Yep.
Because that's
25.4.
2.54, no?
25.4. Equal.
Yeah.
25.4.
Yeah, I've done that. I times that one by 25.
42 mil.
Yep.
Yeah.
So if we want to find out the other way around, the imperial,
Oh, the half inch one.
So these ones here.
we divide them.
Alright, so
Metric, what's a half inch in metric? So you can go half inch, point,
That's the,
500,
yeah, so it's that as well.
500,000,
Tolerance.
half an inch, thousand,
Yep.
Yeah, but.
times that by 25.4, and I'll take what it is in millimetres. So go 0.00,
0.5.
yeah, times 25.4. So that equals 12.7
Two.
millimetres.
So that would be.
Yeah, and like the bigger numbers. So that's in thousands.
Is that 10 or 1 or 0?
No, 0.
0.2.
So when you've got
Zero.
metric, you divide it by 0, so that'll give you the.
50 times 25.4 equals, which makes sense. You know, you're talking a quarter of an inch, which is that pencil,
That's an inch.
and 6 mil, about the pencil, isn't it? So you know you've got it right.
Okay.
So,
Okay, everyone just do a few on the sheet, you don't need to do more than this
I've
one go.
got, that one's 200.
It's easy to go across though,
29.
no dramas.
So
Yeah. You get it, so, and you can put this in reality, can't you? 80 mil, roughly 3 inches.
Yeah.
If you get the number wrong, you divide it all times it all, haven't you?
And that one there, that's just normal fractions, 21 over.
Yeah, you can look that up in the sheet. You know, you can look that up in the 21.
Oh, yeah.
Yeah, you can go 600 and, what was it, 656,000. So you can write that down as 1 inch, 506,000 times the profit. Do it,
So they're all
yeah. Okay.
millimeters. So I can't do one of these, Tim.
I know.
It's the division one, this
Which
one
one?
here.
Okay, don't worry about that one there, it's a fraction.
Yeah,
Yep, just go to another one.
I think I've done
Yeah, all right. Well,
them. I
hang
don't
on.
know.
So this one here, 2132,
Yeah.
there.
Oh, I
So,
wasn't even reading that.
oh no, it was a trick.
So that's
This is-
1,000 plus.
So this would be one,
Yeah.
Nearly
what's that,
one inch.
6,506,000
Yeah.
times that 25.4.
Is it so
Don't have your number. So 1.656 times 25.4.
So 42.06 millimeters, is that right?
Yep.
Well,
You know it's right.
Millimeters, because that's only right. That way.
Yeah, and keep it in reality. It's an inch, less than 2 inches. This number's got to be less than 50 millimetres. So if you do and you think, oh, this ends up being 480 or something,
Yeah.
oh, I've got to divide it so it's on. Okay.
So the 1.656, sorry, which is there, and then you multiply that by 21.4, you do
Yep, perfect.
So now these are divide, because
Okay.
they have a decimal point. So,
Everyone done a few of them and we'll move on?
get it? So this is a decimal point.
Yeah, and that's as hard as it gets. Yeah, it is.
But Phil double, that converts all.
Oh,
He uses his for
Yeah.
taxes and
Yeah.
stuff.
That's
Yep.
not what I've done.
I know,
Exactly.
yeah,
And he said he said it's material tools, metric and metric
Yeah.
tools and.
Because he used to
You're
work on
looking into
American
it.
works.
Okay, we all right?
Better tell him to figure it out.
It's good.
Right, okay, we'll move on. We're a bit time poor. Okay, everyone right?
Yeah,
Just move on.
yeah.
Shelley, you right?
Yeah,
We'll move on, okay? No worries.
I'm done.
Okay, good. So we did that basic exercise. Now, this is what I want to get to, and that's the reason I want to move on. I'm going to show you an instrument you can buy for $10 that's going to allow you to actually get close to measuring some of this stuff. And this is this, okay? This video is a good video because the bottom scale is what you're looking at. So when you're holding your vernier there, and don't pull it out and jam it up the end and don't overdo this little knob, okay? Just let it be nice to it. On the bottom scale, and I'm going to show this video, it's going to allow you to break a millimetre into 10 parts. And why is that important? I'll give you a classic example. When you go to a drill bits and all the ends are mashed off them, and you can't read the numbers any longer, everyone's got a bucket load of drill bits where you can't read it, you can put it up and you can look and go, okay, well that's 11.5. Right? I want a 12 mil hole. That's what the drill went on after. So you keep going through your pile of things and you keep looking until you hit one that's bigger than the hole you've got. Because most of the time you can't read it. So what this does here, instead of holding the tape measure up and going, oh, is that 10 or 11? This allows you to divide that millimetre up very easily by reading the bottom of this scale. Okay? That's why this in the talk, you know, in simple language, is the most useful tool you're going to learn today. You pick up a 1/2 inch to 12 mil bolt, you can't measure that with a tape measure and get a good idea. With this, you'll tell within seconds, okay? That's why these tools are valuable in a toolbox. And this is the only video, we're right there. This is the only video we're going to watch on this because picking up how to read the bottom line of a vernier is what this is about, and this is the closest you're going to get to measuring fine measurements, okay? And I'll touch on the mics, but getting this reality of what this vernier means is probably one of the most useful things you could buy if you own a toolbox, measuring stuff, okay?
Yeah, quick question, sorry.
Yep.
So it doesn't start on the 0, does it? Why
Yep.
is that?
Yep.
So wouldn't that give you incorrect measurement?
Putting this together, the teeth touch, do the two bottom zeros touch? Line up,
The what?
0 and 0.
Yeah, right. So so when I measure, I've got to measure on the 0.
No. The video will explain more.
Okay.
At the end of it, just watch the video, play with the vernier, and as it's going through, just play with the vernier, and you'll see exactly what I mean, because it'll come to life. And this is,
I'm Bob Well, and this is how to read a metric vernier caliper. There are different kinds of vernier scales designed to do different jobs, but they all work pretty much the same way. Today, we're going to look at a metric vernier designed to measure to the nearest 1/50th of a millimeter. That is 0.02 millimeters. See
this
how
is about a hair thickness we measure to.
0.02. Now, the first thing we're going to measure with our vernier caliper is nothing. That's right. We'll measure
So
0.
play with your vernier if you
It may
like,
sound
look at
like
the
a
scale
silly
he's
thing to
going
do,
on.
but we're going to do it for a couple of reasons. Let's do it and you'll see what I mean. You see, when the calipers are fully closed, measuring 0 width, you can see the places where you can take measurements. These surfaces are where the two parts of the calipers line up. You'll also notice that there are gaps in a couple of places on the calipers. These are not places to take measurements, so don't mess up by putting something in one of those gaps. Now, with the calipers closed, you can see where you're supposed to read the main scale. There are two scales on a vernier caliper, the main scale and the vernier scale. I'm going to erase the vernier scale and let you just look at the main scale first. You see, the 0 mark points to the place where you're supposed to read the main scale. Right now, it points to 0. Do you see that? Good. Let's read the main scale first. It's super easy. I'll close the calipers on this workpiece and we'll see what the main scale says. These marks represent whole millimeters. So the reading is 1, 2, 3, 4, 5 millimeters. Just be sure to look at the 0 mark and not at this part. That's a common mistake, and it'll give you the wrong reading. So the reading is 5 millimeters. That's pretty easy, right? Before we move on to the vernier scale, let me show you what it's going to tell us, okay? Let's say when we looked at the main scale, the reading wasn't right on the mark like it was last time. But let's say it looked like this. See how the mark is between 5 and 6 millimeters? It looks like it's a little beyond halfway. You see, the vernier scale is going to tell us almost exactly how far over the mark is. Okay, you're ready to see the vernier scale, but I'm only going to draw the main part of it first. Now, you see the marks number from 0 to 10. Each of these marks represents a tenth of a
No
millimeter.
vernier instead of the 10, 20 or 1, 2, 3.
Tenths of a millimeter, and here's how they work. Look carefully, and you will notice that one of the marks on the vernier scale lines up better with the main scale marks than the others. Which one looks like it lines up best to you? I'll zoom in and let you look. Let me show you a hint about where to look on the vernier scale to see where the marks line up. You see how our pointer was a little more than halfway between marks? That means the vernier scale will line up a little past halfway. Now, do you see the mark that lines up better than the rest? It looks like the 7 is lining up. The 7 means 0.7 millimeters, but this caliper can measure even more accurately than that. I'll redraw all the marks and let you look again.
And this
Now,
is when you
see
need
the
good
marks
eyesight.
next to the 7.
And glasses.
But what is the value of that mark? Remember how this caliper had a label that said 0.02 on it? That is what each mark is, 0.02 millimeters. Let's count up on the vernier scale to be sure we've got it. This 6 would be 0.60, the next mark 0.62, then 0.64, 0.66, 0.68, 0.70, then 0.72. The reading is 5.72 millimeters. Pretty neat, huh? I'm going to let you try a few. We're going to start off easy. I'm going to draw a caliper that only reads to the nearest tenth of a millimeter, just to be sure you're with me. I'm going to show you the overall picture first, then zoom in to let you see the vernier better. Okay? When you see Sparky's pause the video and write down what you think the reading is. The reading is 16.2 millimeters. Let me step you through it, just in case you missed something. Here are the whole millimeters from the main scale, 10, 11, 12, 13, 14, 15, 16. Okay, and you see how the reading is just past 16 mark. So we'll look to the front of the vernier scale for where the marks line up. And there it is, at the 0.2 mark. So the reading is 16.2 millimeters. Got it? Okay, let's go for broke and see if we can read the full 0.02 millimeter resolution.
What are we measuring?
Ready?
No, just watching it and getting the scale
I'll
in
show
your
the
head.
whole caliper, then zoom in to let you see the vernier better. Here we go. Pause the video and write down your answer.
You zoom in, Jan.
Yeah, I don't know.
Now,
No, so
I know
I can
this is
see,
hard.
'cause
So
I'm-
before I give the answer, I'm going to point to the place where the vernier lines up. Does that help? Take a minute and check your answer and be sure it's correct. The reading is 19.16 millimeters. Okay, let's try another one. This time I won't give any hints, but I will zoom way in so you can see the calipers really well. If you get this one, you pretty much know what's going on. Pause the video
So
and make sure you can read
12.
the whole millimeters.
Going past after 12, nearly at 13.
Did you say 12 millimeters?
0.2
Okay,
then.
let's do the hard part.
Oh, it's over half.
Now your scale. I'll zoom in and let you take a closer look.
Something like that.
Remember the trick? See how the reading is beyond halfway between the marks? That means we need to look on the high side of the vernier scale. I'll slide the view down there and let you look. Now here we go. Pause the video and look carefully.
Oh, yeah, hey, clever was.
And sometimes if you don't even, you can see it's 6 between the 7 and 8. Most of the time that's more than fine enough.
What
Yeah,
number is
You
that?
know what I mean?
This is
Yeah.
0.7. So 0.72, 4, 6. The answer is 12.76.
Okay? So, the reason I'm showing you that, this is probably the most versatile.
Vernier calipers are hard to read, but with a little practice, I'm sure you'll be able to do it without too much trouble. I'm Bob Weld, and these are well done.
I'm serious, I really want to do it.
Hi, I'm Bob Weld.
Right. through the vernier calipers and you've basically got the scale, and you know how to do metric to imperial. And the reason I'll give you an example, when you go out to the big bucket of bolts, because no one's ever put them in the right spots, with something like this you can look at it and see, oh, it's 12.7. It's going to be ½ inch, isn't it? And this is 12. Now to go out there and measure and then mess around and try to gauge what it is, it's difficult, but what this does is allow you, like I say, the drill bits. You want it bigger than 11? Okay, it's 11.5. You don't need to read 5, 2, 6, you just know it's bigger than what you need to do.
Can you show me, Tim?
Can you come here for me for a
Yeah,
second?
absolutely.
So show me your drill bit.
Because I'm dumb. Can you tell me, shut up everyone, can you tell me what that is?
Yeah.
What that would be?
So this would be
I just got half.
smack on 7.
There's got to be something.
You've got to look at the zero next to
Smack on 7, see? 5, 6, 7. The zeros.
So I'm taking this as ½ centimetre. That's not right?
Yeah.
Yeah, well, that's
The 10, that's 10 millimetres.
One of those, yeah.
one
That's
zero.
5 millimetres, 6 millimetres, and see how the zero lines up on the 7th one?
Yeah.
That's exactly 7 millimetres.
So it's not 5 millimetres?
No, because look at the zip.
sake.
And like you
You
said,
can't swear, sorry.
see the face here? You're not looking at that, you're looking at the zero.
Okay.
Not the face, that's a mistake.
And
Look
then,
at the zero, do we?
so give me something that's off, because that's exact. So give me something that's not exact.
Right there, that is 10, 11, and it's about halfway along the 11, isn't it? So it's close to anything up to 5 here, the 5 lines up. So it's 11.5.
So when you measure a drill bit for the size tip, you're measuring it up the top.
Yeah, it's the
I'm
same
looking
length
at
down the
the
bottom.
zero, and then because it's not exactly on a line, I'm now trying to match it along a line.
And which one roughly lines up? 5, no, no. Roughly? Probably the straightest one.
No, what?
5 or 4 is very
They all look lined up.
You get it?
Is that my eyesight?
Yeah, you've got to get your eyes in front of it.
Yeah, it has to be tomorrow.
They all
So,
look
so
like.
I'm interested in measuring like zills and that kind of stuff because
Okay, well,
John
just
just
go
pulls shit out all the time and leaves it.
through it. Okay, I'll just hang on one moment. So you don't, 90% of what you're going to do with this is not read down to the 0.02, but just decide if it's 12 or 12.7. Well, you might decide it's 10.3, and you will not 3.2 or 3, you know. So most of the leisure machining, you only need to understand which one of those roughly it lines up with, because it's going to get you within 0.1 of a millimetre, and that's more than enough for 99% of what you're going to do. Right? What he didn't touch on there that made it more useful, when you go to the big bucket of washers that because no one's put them in the right spot, it's also picking the right washer out. Oh, is it 12 or is it 12.5? Right? Well, sorry, is it 12 or is it ½ an inch, which is 12.7? So you can work out what hole you want to do and just start picking these things up. Oh yeah, okay, it's that big. So it's really good for just, even if you get within ½ a millimetre of it, you're going to get it right, aren't you? Because it's just checking stuff. Is the drill bit bigger than the bolt? Measure the bolt. Is the drill a bit bigger so it goes through? Yeah. Oh, okay. You don't know exactly how much you want it is, but you can get close with it and do a lot of measurements with something like this.
It's actually really
And for how much it's worth, okay? And another thing is the depth gauge. Okay, so if you've got a truck chassis and you've got 3 or 4 plates there, you can stick this through, reach in, and let it hit your finger and hit the chassis, then pull it out and go, oh, it's 110 mil through that. Not standing over the top of the tape trying to have a good guess at how the depth is. Okay?
Yeah, and that'd be good for like drilling into brickwork and stuff, eh?
Everything you want to measure. Okay? Everything. It's the most versatile instrument you
Yeah.
get. And everyone, if you've got our toolbox, basically you should have one. It's cheap as chips.
Yeah.
The only thing is, and they're good in the back of the ute, you just wrap it.
No.
It's still in the mid? Yep. Okay. Right, we're back online. Okay, let me finish this off if I can. Okay?
Yeah.
Right. Okay, sorry about that. I'm sure Mia will edit that out. Now, let's put this in reality. Why did you say these measurements are important? Okay, I'm going to give you something very simple. This is a bearing, badly drawn. So, bearings, when they go on a shaft, the internal race can't run on the metal, can it? otherwise it'll just flog it out. So you've got to make an interference fit. So when you push the bearing on, you've got to squish it on. So this internal race here needs to fit over to that, so it squishes on, so it's an interference fit. Okay? And then the bearing will work properly, the race is gripped. Okay? This is where this measurements come in. So you measure the bore of the bearing, and I would machine this 0.02 above the size of that, and I'll put it in a press and push it in. Okay? That's where these measurements come into play. Okay? When you've got to measure with a micrometer and getting down to these measurements, you'll be using a micrometer. So this is where tolerances come into play as a machinist, and basically making the shaft very, like half a hair thicker than the bearing bore, and that's the interference fit, and that's why it slides on and doesn't spin. Okay, so that's where dimensions come into play here. Okay, and these is where you see plus 003, plus 011. This is the dimension the machinist used. So I can make it 30.0010 is the minimum, and 0.030 is the maximum. And I know that bearing is 30 or less than 30. So it's an interference fit because the shaft's only slightly bigger than the bearing. Okay? That's why these 5 measurements are important. That's why we do these 5 measurements. Most wouldn't go near that sort of stuff unless you're a machinist. Okay? But that's where you get those tolerances that matter. That's why you've got instruments such as the micrometers, which will measure down to, let me provide you an example. So this one here, okay, 0 to 25, rounds off to 0. Give an example that I prepared earlier, right? That's the thickness of my hair, 0.050 of a millimetre, okay? So generally we'd work in half a hair to give that, that's what that tolerance is for an interference fit. That's where these instruments come into play as machines. Vernier is just another level up that and gets you close to that. Okay? A vernier will only give you up to 0.02, like that, which is something similar to that. Okay? That's where these fine instruments come into play. Right. Well, we've come to the conclusion. We've done the conversions, metric to imperial, back again, 25.4. If you can't remember the dividable times it, just put it in reality. Is it 50 mil? If you end up with a huge number, then you know 50 mil is around 2 inches. It's got to be around there, doesn't it? So just do a times or divide, if you can't remember which one to do. But it's just simply 25.4. And you'll be able to change all that. And if you have something like this chart here, if you end up with 0.05, 1.5 like that, you look up the chart plus 500 metres, half an inch. You've got exactly 1.5 inches. Okay. So like I say, this is very relevant to what machinists do and get into the fine measurement. But the vernier is the key one. You know, you can measure bolts, keyways, everything with it, and you'll get close enough. Okay? And for the bang for buck to getting a decent measurement, you know, what's the bolt, what's the length, and all those sort of things, it's the ideal instrument. Okay? This fine stuff, you have to own a lathe before you want to go near this stuff. So the vernier is the general use of tool for decision making. Okay, we're answering micrometers and verniers, and yeah, I think that's about it for today. So no more questions? Good. Okay, thank you.